Okay, hello. So this is problem 4 of the 2017 final live solve. Um, as always, like good luck on the final. And also I would recommend you try out this problem first before watching this video, just so you can kind of derive more meaning from it and whatnot. Okay, so let's get to it. So problem 4 says, consider a group of M roommate pairs at Harvard. So 2M students. Each of these 2M students independently decides randomly whether to take Stat 110 with probability P of success. That is taking Stat 110 where hopefully P is large. Let N count how many of these 2M students take Stat 110. That seems like a useful definition. So N is the number of students that actually do take Stat 110. And X is a number of M roommate pairs there are such that both roommates in the pair take Stat 110. Okay, cool. So I always do these kind of things. So like X is the number of roommate pairs. Like I usually just use like indicator random variables for this. So I'll say X is going to be sum of indicators. There's an indicator for each roommate pair, so there's going to be M indicators. And we're looking for the expectation of X. So it's going to be the sum of the expectations of each one from J equals 1 to M. And this expectation here is going to be the probability. And also, like, let's define this. Indicator I is going to be 1 if both take 110 and 0 else. So this is looking for the probability of both taking 110. This is done independently, so each person has a probability P of success, so this is going to be equal to P squared no matter what. So all in total, that's going to be M times P squared as our expectation. Another way to approach this, which is not the way I did this personally, but you can kind of just like, I noticed like upon like actually reading it, it's just like independently decides randomly. There's like a lot of these things. So you can get to that like just from a story argument that every pair of roommates is independent, and this is going to be X is actually distributed as binomial. There's M roommate pairs, so M with the success being both of them taking Stat 110 is M is P squared. So we get an expectation of also MP squared. Yeah, both are the same. Like this is just binomial trials, and we know that by Bernoulli trials, and we know binomials are sum of Bernoullis. So that's part A. Part B is find expectation of X given N. So first things first is that this is a random variable, and it's going to be a function of N, of big N. That's what expectation given a random variable means. Yeah, so I guess like one thing we can do is we can use this representation that I use, the indicator sum thing, and we're looking for expectation of X given N is equal to expectation of I1 plus dot 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 plus IM given N, which is equal to the sum of the expectations. This is by linearity, since linearity still holds when we're conditioning on random variables, of Ij given N for J equals 1 to M. So now we're looking for the probability that both take 110 given N is like N the total number of people taking 110. So the way I guess like that would tell me that we want like this roommate pair, which is going to be something like there's probably going to be some sort of like 2M choose 2 people on the roommate pair. Actually, is that the way I want to approach this? Well, I know on the top, there's going to be some sort of like big N times N minus 1. Maybe it's like N choose 2 students. And then I'm going to have, because I want these two particular. Okay. So what I want to do is I'm going to first choose the first person in this roommate pair, and with probability n over 2m. So there's like 2m total, and then n like desirable, which is like people who are taking style 110. And then for the next person, the next roommate is n minus 1 over 2m minus 1. I think I could also do something like n, big N, choose 2 over 2m, choose 2, and you get the same thing. So that's going to be this probability, and it's all symmetric. Like there's no reason there's a higher probability for the first pair than the last pair because the labeling is completely like arbitrary. So this is the probability. This is going to be the probability of this happening conditional on big N. And this is good because it's a function of big N and it's a random variable itself. And so that's going to be this expectation. Oh, the expectation is the same. So by symmetry, we have, I'm just going to make this tiny if my iPad lets me. No. Oh, whatever. This is going to end up being m for the sum in the front times n minus 1 over 2m minus 1. And I can cancel some stuff out. I can cancel out this m. So I get something like n minus 1 over 4m minus 2. And that will be our solution for B. And just like as a sanity check, it's a function of big N and it's a random variable. So there's no category errors there. Okay, so that's B. Finally for C, let F be the CDF of X. So X is going to be the number of roommate pairs. Find the expression of E of F of X. Your answer can be left as a sum of at most m plus 1 terms. So we have to be careful here. Like you could fall into the trap that like Fx is like uniform because like universality of the uniform. But unfortunately, F is like no longer, like X is no longer continuous. So that doesn't even make sense. You can't like plug a function, like you can't take a like discrete guy and kind of like make it continuous. That doesn't really make sense. I think I made that mistake on my own final, looking at it over here. But here our approach is going to be Lotus. So expectation of Fx is going to be equal to the summation because it's discrete and we're looking at PMFs instead of PDFs over the support. So it's going to be like J equals 0 because 0 roommate pairs is the min, and then max M because M roommate pairs is the max. Recall from like up here, like this is binomial. So I guess you would have to probably do this argument if you didn't, you'd have to do this argument down here if you didn't do the binomial argument in part A. But this is going to be F of, actually, I'd rather use like little x here just to match like Lotus's form. So F of little x times the PDF F of little x. I guess also we could just say probability x equals x since it's a PMF. And this is going to be equal to x equals 0, fx. And then this is going to be m choose x times p squared to the x 1 minus p squared to the m minus x. Let's move this. Oh, and I actually managed to write the whole thing. Yeah. Let me see if everything looks okay. And this is by Lotus. Yeah, okay. So this is actually just the full answer because we can just leave it in terms of we can leave it in terms of P and Fx for various x. So we're good here. I guess the small trap is that it's not universality of the uniform because we have a summation rather than an integral. Okay, so that's it for this problem. good luck studying, and I'll see you for the next problem maybe. All right.